All right, this is a question 1997, question 3, and this is your stat sensei, Mr. Spensei. And we're going to look at a categorical variables and setting up a table to answer some probability questions. So a laboratory test for the detection of a certain disease gives a positive result 5% of the time for the people who do not have the disease. The test gives a negative result 0.3% of the time for people who have the disease. Large-scale studies have shown that the disease occurs in about 2% of the population. So let's take a look at this real quickly. First off, I want to point out that we have a Rule 1 violation. This should be 0.003 or 0.3%. So be careful of that. Don't let that get you. Now, when we're looking to set up a table, we need to identify, first off, why is it a table? Typically speaking, if we have two variables, which we do in this case, we have the variable of whether you have the disease and we also have the variable about testing positive or negative. So test results and your health. So anytime we have two variables, good chance it's a table. And it's almost guaranteed to be a table if it's something with three values and they're looking for a probability. So let's take a look at this thing. So what's the probability that a person selected at random would test positive for the disease? Well, we need to identify the variables or the number that's associated with only one variable. So the laboratory test for detection of a certain disease gives a positive result 5% of the time for people who do not have the disease. So we positive and do not have the disease, we have two variables, so that's not the 5%. The 0.3% is test negative for people who have the disease. Again, we are two variables. Large scale studies have shown that the disease occurs in 2% of the population. So that's the health status. It's only associated with one variable. It's not associated with being positive or negative. So this is going to be that 2% is where we're going to start. So I'm going to go ahead and draw my table out. And I always start with that number going there every single time. It just makes life easy. 1.0, because it has to sum up to 1. We know that this is 0.98. Well, what is that? This has the disease. This is no disease. And this is positive and this is negative. Well, immediately I write these small without even really thinking about it once I have them placed. So this is 0.02 and this is 0.98. This is also 0.98. Now, gives a positive result. So we're looking at positive 5% of the time for those who do not have the disease. So positive and no disease is right here. This is 0.05. And this is 1 minus that, which makes it 0.95, but I'm going to go ahead and write that. Let's go ahead and multiply these out. This becomes 0.049, and this becomes 0.931. And the test gives a negative result, so we're looking at the negative row for those who who have the disease. So negative who have the disease, that's going right here. This is 0.003. This is going to be 1 minus 0.003. And we'll go ahead and multiply those out. And I'm just going to do this one real quickly just because I want to show you something. So 0.02 times the 0.00, oops. And I end up getting 6 to the negative 5. That just means I need 4 zeros. So that's going to be 0.1, 2, 3, 4. And then we had a 6. And then 0.02 times the 0.997. And that's 0.01994. Now, if everything works out correctly, this plus this will equal this, and this plus this will equal that. I'm going to add this row up, and I get 0.06894, and this row adds up to 0.932. 0.106. And they want the probability a randomly tested person will test positive. Well, the probability of positive, because we always have to make sure we actually answer their question, is 0.06894. Just because you have the calculation doesn't mean you're done. You need to make sure that you've identified that you've done the work. So there's a probability positive. Now the part B should be a lot easier now that we've set up the table. So what's the probability that a person selected at random who tests positive does not have the disease? So probability they test positive. So this says from the group, what's the probability the person selected from a random who tests positive or is from the group or a given. So this is an intersection and given problem, or this indicates given. And it's given that they're positive. And if anytime it's given, we know we're going to have an intersection. So this is intersection over given for the does not have the disease. All right. So what we're looking for is a probability of no disease given, that line means given, that they test positive. Well, the probability of positive is 0.06894. And because it's always intersection over given, I see, oh, that's 0.049. So 0.049 is my numerator. So 0.049 divided by 0.06894 equals, and we end up getting 0.7017. And if you have all of that work shown, you get full credit for that response. And I think that's not that bad. Appreciate you guys watching. Hope to see you on the next one.